Welcome to video 6 in a series of introductory videos for SolidCAM. This video's topic is the Profile Toolpath. Now, Profile Toolpath is one of the older toolpaths from SolidCAM. You can consider it as a routering toolpath in that the chain that you select in your geometry, the tool will follow that chain exactly, either on the left side, the right side, or down the center. Okay. And you can access that toolpath either in the SolidCAM Operations tab on the ribbon, right here, or right-click on the operations folder, add milling operation, and click on Profile. The workflow on the left side is the same for all our toolpaths. We begin by choosing a geometry. In this case, I'm going to choose a geometry from my Mac 3, which is my offset on this face. And we're just going to do this slot real quick. So chain selection inside of 2016 is simple as before, except we have some new options. So I'm just going to choose this edge here. A highlighted yellow is the first element in this chain, and the blue highlights indicate the other possibilities for this chain. I could either continue along the constant Z direction with that curve right there, or I can go down the vertical direction to continue this chain in whichever direction I so choose. And we actually have the ability to toggle between those options. In this case, I have 4 options. Either I can go in this direction, down, or change my direction and go in this direction here with this curve or that vertical line. And we could toggle through those options here. That isn't to say that I can't just choose the edge like before, but again, it just gives us an option here that if we don't want to go and individually choose small line segments or small arcs, I can just toggle through the options, and then using this function right here, just continue to add the segment as I go along to complete the chain. Now, that is if I were to do it manually. But just like before, we have something that will find the rest of the chain in the same Z direction, in the same Z plane. Currently, it's called constant Z propagation. If I click on that, it finds the rest of the chain. Likewise, if I delete that chain once again, uncheck that box, click on that element once again, and if this were part of a surface where all the edges of my chain are tangent, they're not necessarily in the same Z plane, but I still like to take advantage of that auto selection function. There is now a tangent propagation button, meaning that as long as the elements of that chain are still tangent to each other, there's a flow to them, I can click on tangent propagation and then create my chain. So let's accept that geometry and we'll continue from there. In this case, we're going to choose a tool. I'll choose my 1/4 inch flat end mill for my list. Levels, such as always, we're just going to choose either a face or a vertice. And I'll drop it down in the delta box by 30 thou. The technology section of the Profile Toolpath is actually one of the more expanded technology sections inside of SolidCAM. You have a lot of control over this toolpath. You can choose to either do a finishing operation by checking that box, a roughing operation by checking that box, or both. Today we're just going to do a roughing operation, and the difference between the roughing and the finishing is you see that the wall offset and the floor offset are open when I do roughing, but if I do finishing, I don't have that option because it assumes I'm not leaving any material on the wall or the floor in a finishing operation. I'll just give us a step down of 50 thou, just something we can see that when we generate the toolpath, we have a lot of passes. I'd like to see some passes to show you the rest of the toolpath here. One of the other things I didn't show you was the clear offset. Now, it doesn't really apply to this operation because we're inside of a closed chain, but the clear offset allows you to add a lateral step over. So you can actually tell it how much material from that chain going outwards you have. So if I were to say there's 50 thou or 500 thou material along that chain, and then I wanted to do a step over of, let's say, 130, that's how I can add a radial step over to a profile operation. But in this case, because we're inside of a closed chain, that's not really going to apply. So I'm going to turn that off. You'll see also that if we have the finish and the clear offset engaged, once again, we have independent control over the compensation during those different modes. And that is new to 2016 as well. So I'm just going to turn those off. I won't use any compensation. And we're just going to save and calculate this operation so we can take a look. Okay. So much as always, we have the link section, lead in, lead out, I'm actually going to change it from the arc, which is the default setting, to normal. I just want to do a normal entry lead in, lead out to the part. And now we actually have two options here. We can either define the length of that normal lead in and out as either a percentage of the tool or as a value. In this case, I'm going to change the value to maybe just 20 thou. We'll save and calculate and take a look at that. So now I have just a normal entry into the part. Going back to the technology section, if I don't like where that's actually starting, so because I'm doing a normal lead in, lead out, I don't want it to start exactly in that corner. I might want to start it maybe somewhere in the middle. I can actually go to this geometry button right here and make modifications to the actual geometry outside of the real geometry that I chose from the part. So highlighted in yellow is my actual geometry, and in red is representation of the tool's diameter. Now I don't want it to start there. I want it to start it, let's say, somewhere in the middle. Well, I just go to start position, and I can shift it either along that one edge, or in this case, I currently have set the whole chain, meaning that if I click anywhere on that chain, it changes the start position of the tool. So I'm just going to leave it there, arbitrarily there. But if I really wanted to, I could find a point. I could project points onto there. It's really just click anywhere you want to start, and it'll put it on the chain. So let's just go from there. Save and calculate. And now the tool actually plunges and starts from inside the center there. Okay. Now, what if I wanted to actually do this slot in a more traditional manner? Use a tool that is actually the size of the slot. Well, I've done a save and copy. Let's go and reselect the geometry to just this edge here. Now, I don't need to actually create any new sketches or anything like that to get the tool to ride down the center of that slot. I'm just going to use the one side of that slot. And the tool, let's choose a tool that is actually the size of the slot. In this case, tool 5, which is the 3/8 tool. Levels are the same. I'm just going to choose a vertex that represents the bottom edge. Okay. And under technology, I still have it set to tool side left, meaning that it'll climb mill along that line, which should give us what we're looking for. That edge actually stops right there. The tool will come down. It will complete that. But if I wanted to use the center of the tool, so no compensation, none of that stuff, I'm just choosing to slot this tool just by going right down the center line. Well, I don't need to actually sketch that center line. What I can do is change this to tool side center. So the tool actually will follow the chain that I selected down the center. And if I go back to that geometry section, you can see now that the representation of the tool is following that line exactly down the center. But I need to shift it over. Well, I actually have this modify offset right here, and I can shift it over by whatever amount I want. So let's do 100 thou positive, which will go that direction, or negative 100 thou in the opposite direction. So you can see the purple line represents the actual selected chain, and the yellow line represents my modification of that chain. So now the tool actually followed the yellow line. Now, I don't have to actually guess at the size of this slot. I can actually use this button right here, take half offset, let's just set that back to 0, take half from selected offset, meaning that the next line that I select, it'll find the halfway distance between the two, and now I have the center line of that slot. Let's take this a little further, and let's say that this geometry was not truly representative of the slot. I might want to make it less than that. Well, I don't have to go back to my designer to get them to reformat this, to redesign this. I can actually use the extension section and put in a negative extension, meaning that I'll trim back the toolpath by a certain amount. So if I say by 200 thou, let's change that to maybe only 50 thou, maybe even 100. Whatever number I put in there, it will trim back that toolpath. Okay. And we'll trim back the other side as well. So if I trim that toolpath by, let's say, a ½ inch on each side, I now don't have to create any geometry. I don't have to create any sketches to get that exact slot. I just have to use a line. Now here, the slot is actually defined for us by the design. But if you had any reason why you wanted to add just a clearing path and you don't actually have chains or geometries that actually denote that, you can modify any line or any arc you choose from the part to get this sorted toolpath. Okay, let's just click the green check mark there. Save and calculate. In this case, we're not going to have a lead in, lead out, so I'll just turn it off. And there we go. We have a toolpath that plunges in and does a slot. Okay. Now, if I make a save and copy of this toolpath, our original toolpath, rather than doing a constant step down, meaning that it plunges in, does a lap, and then feeds back in and does another lap, we actually have what's called a helical depth type. This will allow us to apply a constant Z force, constant downward force to the tool while it actually goes in the Z direction and progresses down with a helical depth. And let's take a look at what that looks like. There's no retraction. There's no feeding plunge. Basically, with each lap, it'll do the first depth of cut. So there's a constant Z action, which actually pulls the tool in there. It's a much more accurate toolpath. Okay, so you have that option there. Now, with the profile operation, we actually have the ability to add a chamfering cycle to it as well. And we'll show you what that looks like. So I'm just going to add another operation, another profile operation, this time on my Mac 1, my top side. I'm going to click on this edge right here. Again, I'm going to use constant Z propagation to find the rest of the chain. This time, my tool, I'll use a chamfer mill. Levels, I'll choose the top face of the part. And there's no chamfer on the design, so I'm just going to add one to it. And let's just say we add a 20 thou chamfer. Under technology, just like before, tool side left, we're going to do a finishing pass, meaning that I'm not going to leave any material along the wall. In this case, I'm doing a chamfer, so that wouldn't make any sense. And lead in, lead out, I'm going to change it to a normal, 150 thou lead in, that's fine. Under technology, we're actually going to go down to here where it says rest material / chamfer. Now, to see how rest material works, I reference you to video 5 where I showed how it worked in the pocketing operation. It works in a similar way here. So I'll let you go to that video to see how that works. But here, I'll show you how the chamfer works. So if we click on chamfer, it opens up the second tab here to show me that I can apply a cutting diameter. So this will be separate from the diameter you use to define the tool. This will be the diameter that is used in your cutter compensation and such when you do this chamfering operation. And all this cutting diameter is, if you see in the bottom left corner, if you define your tool with the proper angle, you've defined your tool accurately, SolidCAM will take that cutting diameter and find where it sits on the cone so you can use that to actually apply the chamfer. So let's take a look at what that looks like. So as you can see, if I do a quick simulation in HostCAD of that, the tool will come down, lead in, and there is my chamfer. Now, right about this point here is where that 20 thou that I said the drop is, and it found that right there as my 50 thou diameter of my chamfering tool. Okay. So like I said, the profile toolpath is a routering toolpath. It follows that tool exactly. You have chamfering options, and you can modify any geometry you choose to add offsets, extensions, start points, that sort of thing. You never have to create sketches to get the profile to work. You use the geometry right from the part. If you have any further questions outside of this video, you can always call us at the main tech support line at 1-866-975-1115, extension 2, or you can watch the rest of the videos for details on the other toolpaths available from SolidCAM. Thank you for watching.